Hey kids. Bit chaotic today behind me. It's been a chaotic day, but it's fine. I've had some hot cocoa, so I'm back up, baby. We're gonna do some cleanup today. Some spring cleaning, some winter wrap up. Because it's getting a little bit messy here. I'm not a big fan of hard-coded shaders. I don't know if you are, but I sure would prefer not to have them there. So I thought we'd improve the shader code a little bit, or the shader import code, I should say. Moving up to files, they're a little bit less annoying to work with, and they just make our code a little bit less messy. So let's do it. I'm gonna create the file. Oh, excuse me. Oh, I'm gonna create a file called let's call it shader.h. So I'm gonna make a header file, and in here we're gonna make let's do a GLU int my brain hasn't fully awoken yet. Yeah, okay, so let's call it load shaders. Let's do load shader program. All right, and we're gonna give it two file names or file paths. So we'll do vert path and frag path, like so. And so this is gonna create the shader program and load the shaders from the files, compile them and everything, link the program, and then just return the handle to us, because we really don't need access to anything more than that. We just want the handle to the program when it's all done. Having the shader handles is it's useful, of course, if you want to reuse shaders, for example. But in our case, we don't really care. It's fine if we use the same source. We just make new shaders. But it's GLU, it's undefined, so we need to import, or sort of include GL. I think it's glue. I'll import glue. Yeah. So let's define this function in a C++ file. So I will create a shader.cpp. Like so. Yeah, so I'm gonna use this thing. Actually, no, I don't need that. It's gonna do that. Whoa, okay. There we go. So let's include shader.h, and then we'll define the function here. I'm just gonna return a 0 now, just to see if it actually compiles. I got some warnings, but it's fine. We still got a success, so that's good. Cool, so what's gonna happen here? So let's start with loading one shader. So I'll make a function to load a shader. Load shader path, and then it will have a GLEnum type. So this load the shader program will call this load shader function twice, one for the vertex and one for the fragment shader, and it's gonna pass in which type of shader it's gonna load in this type argument. So how do we open a file? Well, I mean, there's a billion ways of doing it, but I'm gonna use fopen because I like fopen. So we do file equals fopen, and then it takes the file name, path, and then the mode as a string, R, so R for reads. And we got to include this, and I think it's in S3IO, if I'm not mistaken. Let's compile. Okay, so we shall C++ is... It's a little bit paranoid, so it's telling us fopen, this function or variable may be unsafe. It's dangerous. Consider using fopen_s instead. We could define this this one here to get this error message to go away, but let's just do what he wants. So he wants to use this s variant instead, and that takes a pointer to a file pointer, and then the rest is the same. I actually don't know why this is more safe. Yeah, I don't know why this is more safe, but you know, it's telling us to do it, so let's just do it. So we'll do a pointer to our file pointer, and then file names, path, and then mode is R. And R stands for read. So we want to read the file. Great, so now this file pointer should be a handle to our open file. The specifics of open doesn't really matter. I mean, again, you can use file streams or, you know, create file or whatever you want to do. It doesn't really matter. Like loading a file there's not one way to do it. I'm just doing this one. If you remember it or not, it doesn't really matter. Okay, so we open the file. Then we want to create some kind of memory buffer to just hold the file data. So I'm just going to make a static char here. I'll call it, let's just call it buffer, like so. Then I'm going to do fread. Whoops. So it wants the buffer pointer, so that's going to be our buffer. Element size. So fread takes two like it takes like two variables or two arguments to determine how much data to read. In this case, it's like how big is each element, and it's just one because it's a we just want to read bytes, so just one byte at a time, and then it needs to know how many bytes do we want to read. We want to read 1024 and our file stream there. So we just give the handle as the last argument. Let's see. File could be 0. This is not here to specify. Okay. It's telling us that this file could be null if the file if the file failed to open, which we will take into account soon. But okay, so this will read 1024 bytes from the file. If there is that many, of course. If the file is not that big, it will just read up until the end of the file. But that's fine. We don't care. Good. So let's print it then. I'll just do print loading shader like that, and then I'll do new line and this print it new line. So we'll do loading shader path, and then we'll print the buffer just to see kind of what's happening there. So we'll just do load shader word path. Let's do 0 for now. Load shader must return a value. Oops, let's just return 0. I usually like to take this like one step at a time, just to make sure like I really understand, or like really I'm not making assumptions about what fread will do. I just like to sanity check every step of the way to find bugs, or just to sort of get a feel for whatever it is I'm writing. So let's just call it here. It doesn't really matter. Load shader program, and then we'll do. Let's just create. Actually, let's create a file first, so I know what I'm gonna type in there. Let's see. So I'll create a new folder here called shaders. So in the root of the project. And then I'll make a new text document. Let's do it test.vert. Unusable. this unusable file, and then test.frag. So I'm making one file for the vertex shader and one file for the fragment shader. I usually call them .vert and .frag. Obviously, it doesn't matter. You can call them whenever you want. You can call them VS and FS is ones, and sometimes it's like .shdr or whatever is what you want to call them. I usually go for vert and frag. But yeah, so let's see. So I want to load shaders slash test.vert, and the fragment shader is going to be shaders test.frag, like so. And then we'll do GLUint program. No, let's not do that yet. Actually. So it's complaining that there's no about this, and we gotta import it. Include them in shader.h. There we go. Let's see what happens. And it worked. Good. Let's F5. Oh. Okay, loading shaders test vert. Okay, and then nothing is written because we haven't written anything in the file yet, so that makes sense. Important to note, where I just wrote here like shaders slash test vert, and you might wonder relative to what. How does it know where the shaders folder is? And you can find this if you go into project properties and then and then use debugging. Sorry, you'll see a working directory. That's gonna be what the current directory is gonna be when it's debugging. So when it launches the game or the program, this is what loading files will originate from, and it says project there here. So that's just expanding to the project directory. And if I look here and edit, we'll see here it's dprog graphics course. So that's just the root folder right here. But this is because I put the project in the same folder as SLN here. And here again, it's like, it's always much easier. It's always much easier to have them in the same folder because of stuff like this. Because, if we haven't had it in the same folder, then we might have gotten an error because we could put the shaders folder, in the wrong root. We put it in the solution root and not the project root, and it will just become a lot very confusing. So as a trap fall, that's a pit. That's a trap. That's a pit. That's a trap you can fall into. Cool. So let's actually write something in our shaders file, should we? I will just take a quick break. So be right back. Let's write some shaded files, shall we? So if I hit refresh here, yeah, there you go. It should show up here. So let's start with the vertex shader. So I'll do define. No, not define. What am I doing? Version 330 core. In vec2, a position. I'm just writing the thing we were writing before, but this time in an actual file. GL position is equal to vec4 a position 0, 1. Let's run. Hooray! All right, so it's printing out what we're expecting, so that's good. So let's do the same thing with the vertex shader. Oh, oops. Let's see, yeah, here, fragment shader. Version 330 core, out vec4 o color, void main, o color is equal to, let's do another color, let's do hot red. No, I want to do that. Let's do green. Yeah, there we go. Looks pretty good to me. So I'm gonna go into shader.cpp here and make sure we do the same thing with the frag. So there we go. Same. Alright, so that looks okay. So here's loading shader test frag. Looks okay, but what is this? It should end here, but then there's like this 1.0 semicolon. Okay, so why is that? Why is this here? So this is like I guess a C++ thing. It's what's the word I'm looking for? It's a product of the way we're doing in our file loading. I'll give you a hint. It has to do with having this static buffer here. If you don't know what static is, that's fine. I can tell you that it's a this 1024 byte buffer is created when we start the program. That's what static means. So static means that it's not a variable inside of this that gets, created in this function and destroyed when the function leaves. It's always there. So when we call the function once and then leave and then call it again, it will be the same value it was before because it didn't get destroyed. It's still there. So that's what static means. So what's happening, if I paint this, let's say, grab my Wacom. Let's say, let's do that. All right. Let's say we're loading the string hello into our static buffer. Hello. That. Let's make it monospaced actually. It will make stuff easier. So HELLO, and then there's gonna be a 0 at the end. There we go. And then next time we come around, this memory is not cleared. All right. So it's still hello. It's still in that memory since it's static. So what's gonna happen is that we're gonna load. Let's say we're loading the fragment shader, which is shorter. So let's say it loads high. All right. So it's gonna load high. HI. And what that does is that it loads it into the first 2 bytes here. So these 2 bytes becomes high. But then the rest is still there. The rest doesn't change. So that's why, and it will become a hello, which is should be a word. So that's what's happening. So in our case, we're loading the vertex shader first. So that gets loaded into the static buffer. And then after that, we load the fragment shader, which is shorter, which means that the fragment shader will be sort of filling up the beginning of the buffer. But then at the end, it's going to be sort of the remainder of the vertex buffer that did not get overwritten. So as we can see, this like 1.0 semicolon and then ending bracket, that's just the end here of the vertex shader. Sort of lopped at the end of our fragment shader. So it's a drawback of the method we are using, but it's fine. It's quite easy to work around. Probably the easiest way is to just lop a 0 at the end of our string. So the strings in C++ is null terminated, which means that it keeps reading until it hits a 0, like not the number 0, but the byte 0, which is a special character, which is telling C++ that this string ends here. There's nothing more. So what we can do is that we can sort of insert that 0 at the end of our fragment string. And what that will do is that will replace this L here in the simplified example with a 0. So when OpenGL is reading this file to compile the shader, it will go like, okay, H and then I and then, oh, 0, okay, the string ends here. So it won't read the garbage here after the 0. That's effectively not there. Okay. That's probably the easiest way to do that. So how do we push a 0 in at the end of the string? Well, fread conveniently returns how many bytes were read. All right, so we're telling it I want to read 1024 bytes, and it's gonna say like, hey, I got 5. that's how long the file is. Here you go, 5 bytes. So it will return how many bytes were actually written into the buffer. So I'm just gonna save that into an integer. So we'll call it file size. Yeah. Cool. And then what we'll do is just that buffer file size is equal to 0. All right. And I'm just gonna give you like a little quiz, like why is it not file size plus 1? Right? Because it kind of seems like it should be plus 1, right? It's like at the end, but we don't want to replace the last letter. We want to replace the thing after the letter, right? So I'll just leave this a little thought teaser. So let's see what happens. Okay, so we're loading our vertex shader here, and here's our fragment shader, and magic, it's ending right at that final bracket, so we don't get the garbage afterwards. Cool, great. So let's compile this into, or first of all, let's do some cleaning up. All right, so we're gonna do for close of the file. So we want to make sure we clean up after ourselves. So yeah, this will close the file. Otherwise, we're gonna keep using it, which means that if you wanna write the shader while the program is running, you're gonna get like, oh, this file is open somewhere else because we didn't close it in our program. So yeah, we want to clean up after ourselves. I'm gonna remove this printing out the actual code now because we trust in our algorithm. I'm actually gonna put this at the top as well. So, and actually I put the close there as well because we don't really need to keep it around after fread. It's actually fread and fclose, but I like to call them fread and close. It's pretty funny. Okay, so let's see. Load the file, and then we'll have create the shader open GL object. So we'll do shader is equal to GL create shader, and here's the type. So conveniently I include that as an argument, so we'll pass that in there, type, and then we'll do GL shader source. So we'll pass in a source. So we've got shader, and then it's count, so we'll have one source again, and then it's a pointer to the string. Here's where, unfortunately, let's just let that be for a while, and then it's a length. So again, we're not terminated the string, so we'll just pass in null pointer, or null. Let's just do null. Okay, so here's where C++ is a little dumb. You'll see here it says like argument of type char pointer 1034 is incompatible with parameter of type const gl char pointer const pointer. And I am not 100% sure what goes wrong here. I think for some reason taking the address of a static array is giving C++ a little bit of like giving it a little bit of a problem. So what I have to do actually is that I have to get a sharp a pointer just to the buffer. So I'm just gonna do buffer pointer is equal to buffer, which is converting it into just a regular pointer and not a static array. And now, so this pointer and the buffer, I mean, they're the same thing, but in C++ they're two different types. But now I can pass in the pointer to our buffer pointer. There we go, or the address of our buffer pointer. I don't fully understand why this happens. I don't get why you can't just do address of a static array, but you know, C++, it's what it is. Okay, so we're gonna upload the source and then we're gonna compile it. So we're gonna compile the shader. There we go. And then we want to check the results, or we want to check the logs. So we're gonna do print result of compilation. Oops. So here we're gonna do gl get shader info log. So we're gonna do shader. Again, this is the exact same thing we did before in main. Now we're just doing it in a nice function. So buff size, and you know, it's kind of nice we have this buffer because we can reuse that buffer for this function here. So we can sort of use the buffer in two places, which is nice. So I'll just do 1024 length, we don't care, null. And then info log is just a pointer to the buffer, so we use the buffer. And then we'll print whatever the buffer is. Yeah, let's just do that. Whoops. Great. And then we'll return the shader. Cool. Okay. This is a warning, but this warning, it doesn't even work. Let's see what happens. I'm not getting an output here. Wait, why is it still printing the... Oh yeah, I did something wrong here. Oh. Oh, right, of course. Of course, it's printing the source here. And why is that? It's the exact same thing where we're getting the shader info log, but if there is no log, it just returns I wonder if it even it's interesting. I wonder if it even null terminates the info log. Might not be. Let's try. So, you know, it's not obviously it's not giving us any info log. Nothing gets written to a buffer. So when I print the buffer, I'm just printing the file again. Because that's what was in the buffer before. So I'm just gonna null terminate it and see if that's good enough. So I'm just gonna null terminate at the very beginning. So I'm gonna set the first byte to a 0. So that's effectively resetting the string as far as C++ cares. Okay, so we're not getting anything. So that's good. Which kind of surprises me for the reason that it might be that the shader is just invalid. I'm pretty sure this is just going to be some invalid handle because I'm passing a type here into GL create shader, but we just passed in 0 here temporarily, right? So let's pass in the actual. We're going to do a vertex shader and a GL fragment shader, like so. Let's see. Okay, so it's loaded. Okay, so I'm actually curious what's gonna happen now if I actually insert an error into this. Let's do some garbage. Okay, there we go. Loading shader. Okay, so we get some errors here. I wonder if this error is actually longer than the shader was. So let's just do like 3. Let's just pass in some invalid arguments here. Hopefully that gives us like a little bit shorter error message. Yeah, there we go. 2-image data in typed constructor. And it does seem like it does null terminate the string, because this string is surely shorter than our shader, so we should have gotten garbage afterwards if it did not null terminate the string. So I'm thinking infolog returns a null terminated string. So that's good. So honestly, in that case, maybe it doesn't even... Maybe I spoke too soon. Maybe this isn't even a problem. Maybe I don't even need to do this. Because maybe it was that the shader handle was invalid, so it wasn't even running anything. So maybe now... Okay, let's get away with the error. Let's take away the error. I don't need to compile when I change shader. Okay, so yeah, okay, so that was... Okay. That explains. I was a bit surprised. So now it does return the info log because our shader is actually a valid handle, because we're creating it with... Before we created with type 0. So it's just like, you can't do this, and it just returns an invalid handle. Now it returns a valid handle, and when you do get infolog with a valid handle and there's nothing there, it just null terminates the string. It just returns like an empty string, so it's just a 0 essentially. So that fixes that null termination for us. We don't have to do that manually. Great. Let's do the program. So we'll do glu int vert shader and glu int frag shader, and then we'll create the program. So we'll do program is gl create program. So we'll gl attach shader, program vert shader, gl attach shader, program frag shader, program, then we'll link it and return it. Cool. Oops. Like that. Yeah, looks pretty good to me. Let's see if it works. So I will actually replace all of the code we had before. So I'm just gonna remove this hard-coded stuff. Like so, and I am going to oh, there it is. So remove all of this. There we go. And replace that with our new cool function. There we go. So we're loading it from file and then getting a handle to the shader program, and we'll just use it. Just like that. What could fucking possibly go wrong? Nothing, apparently. I was surprised that worked. You guys might not have been so lucky. So now we can a little bit more easily change this. So let's do it. Let's make it a little bit more blue, for example, and then we can just restart the program. And there you go, it's more blue. Sweet. So now we've loaded files. I'm gonna one pitfall that I know I have not really talked about is you might. I mean, this is way too late for me to be explaining this because you will already be just lost and writing to me in the Discord. But if the include failed for some reason, remember that we put our files in. Actually, no, it shouldn't fail. No, never mind. Let's just talk about this in the Discord if it happens. If you get any errors with includes, just ping me and we can talk about it. otherwise, yeah, that's it. We've cleaned up the shaders and loaded files, so that's cool. So I'll see you guys next video.